we're going to look at the behavior of the polynomial function as x approaches positive and negative infinity. We call the polynomial function px of the degree n is in the form of an x to the power n plus an minus 1 x to the n minus 1, and keep going in the lower degree down to a1 x to the first power plus a0 x to the 0 power, which is a constant term. And the leading term would be the an x to the power n. The degree is n, the leading term is an. So we're going to determine the behavior using these two key terms. The an, whether it's positive or negative. The n, whether it's even number or odd number. So we're going to have 4 combinations. I'm going to use the simple function as we can use for the guideline to determine in general. For the case of n is even and an is positive, like the function y equals x squared, this case the coefficient is 1. That means your an equals 1 and the n equals 2. An positive and n is an even number. I'm sure you are familiar with the parabola graph. The graph is like the U shape that opens up. So we can use that as a guideline. For the case of an is positive and n is an even, we can say that as x approaches negative infinity, the y approaches positive infinity. As x approaches positive infinity, the graph or the y approaches positive infinity, as we see the behavior of the graph in this direction. So the summary of this case is x approaches negative infinity, the y or the function value approaches positive infinity. X approaches positive infinity, the function px approaches positive infinity. For the case of n is an odd number and an is still positive, the easy function that we can refer to or use as a guideline, for example, y equals x. That means the leading coefficient is 1, the power n is 1. So we can use as this case, an is 1, which is positive number. The n is 1, which is the odd number. The graph of the function y equals x, which is the straight line. If we use this as a guideline, we can see that the behavior of this situation as x approaches negative infinity, y approaches negative infinity as the graph is going down on the left there. For x approaches positive infinity, y approaches positive infinity. And same as the guideline that we use as y equals x. You see the graph, like on the left side is going down, the right side going up. And to summarize for this case, x approaches negative infinity. The function value px approaches negative infinity. X approaches positive infinity, the function value px approaches positive infinity. Gonna look at another case today, n is negative. In the case of the n is an even number, we use the same function as a guideline, like the parabola graph. Y equals x squared. This time we're gonna have the coefficient as the leading coefficient as a negative sign. So we can see that the an is negative 1, which is negative number, n equals 2, which is an even number. This is the upside down parabola. The graph opens upside down. So we can see that as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. And we summarize in this case as x approaches negative infinity, the function value behaves like approaching negative infinity. x approaches positive infinity, the function, the graph approaches negative infinity. And the last case, the case that an is negative and the n or the degree is an odd number, similar to the function we used in the case of the n positive, as we use the graph of the y equals x, right? So this time I'm gonna have y equals negative x, which means the an or the coefficient -1, the n, which is the power, is 1. This is the graph of the line, and this will give the graph of the line with the slope negative, with the behavior that we know that is kind of the graph that's falling down or have the decreasing behavior or the slope negative. So we can use this as a guideline as x approaches negative infinity, the y approaches positive infinity. On the right side of the graph, x approaches positive infinity. We write this in the better one. This is x approaches negative infinity, or the left tail of the graph. Back to the case of x approaches positive infinity, y approaches negative infinity. So we can summarize in this case as for an negative and n an odd number, x approaches negative infinity, the px approaches positive infinity. X approaches positive infinity, px approaches negative infinity. Now let's take a look at the example. On the table here, we have the polynomial functions. We're gonna find the degree, the leading coefficient, and describe the behavior of the graph as x approaches infinity and x approaches negative infinity. In part A, polynomial function px equals 5x squared minus 3x plus 12. The degree, the terms in the order from the higher power to the lower power. So the leading term for part A function is 5x to the second. That means the degree is 2. The leading coefficient is 5. In part B, the function is x to the third minus 9x squared plus 4x plus 14, also in the right order. So we have the leading term as x to the third. Identify the degree as a power 3. Leading coefficient 1. There's no number here, that's to be 1. In part C, we don't have the simplified form, so that means we have to work it out a little bit. Basically, we just look at the leading term. So you don't have to do all the way. So you just look at x times negative x, 8x, and times 5x. So the leading term would have been from the product of negative 8x times x times 5x, or negative 40 x to the third power. That's your leading term. So we got leading term. So we can see that the power 3 and the coefficient negative 40, the degree 3, leading coefficient negative 40. Now we can just look at the cases from the 4 combination cases that we looked before. Degree 2, 3, and 3. 2 is 2 is the even number, 3 is the odd number, and also odd for for part C. Leading coefficient, so this is positive, and this is negative. So the case that the leading coefficient positive and the degree is an even, the graph, let's adjust the screen real quick. Gonna behave like something that we are familiar with, like even power, positive coefficient. So rising on the left, rising on the right. So that means the px approaches positive infinity on the right and the px approaches positive infinity on the left. For part B, the degree is an odd number and the leading coefficient is a positive number. So we can refer to the baseline function or the function we use for the guideline like y equals x. That means as x approaches positive infinity, the graph is rising. So px approaches infinity. And on the left side of the graph, the function will approach negative infinity as going down. And in part C, degree is 3, which is an odd number, and the leading coefficient is negative number. If you think about the graph like y equals negative x, so the graph is going opposite as what we did in part B. Therefore, as x approaches infinity, the function will go all the way down to negative infinity. And as x approaches negative infinity, the function or the behavior of the graph will approach positive infinity.